P4.5 series circuits. So I've got a circuit here that shows that would be for a torch. So we've got the cell there and then the bulb. In the torch circuit, the bulb, the cell and the switch are connected in series. They're all in one loop, so they're all next to each other. In the same number of electrons passes through each component every second. So the same number of electrons passes through the bulb as goes through the switch. So the current is the same that passes through each component. So it's the same here and it's the same here. In a series circuit, the total potential difference of the power supply is shared between the two components. What this means is, so each electron from the cell, which is here, remember a cell is this, two or more cells is a battery, passes through the two bulbs. They push through each bulb by the cell. Because each electron in the circuit passes through the two bulbs, the potential difference of the cell is shared between the two bulbs. So that plus that equals the potential difference. Cells in series, so a total potential difference of cells in series is the sum of the potential difference of each cell. So an electron would get the same push from a battery of 3 1.5 cells, because 1.5 times 3 is 4.5, as it would from a single 4.5 volt cell. This rule only applies if the cells are going in the same direction, so if they're pushing the electrons in the same direction. Moving on to this bit, so the resistance rule for components in a series. So the current through the bulb in the diagram that I've got here is 0.1 amps when the bulb is dim. To work out the resistance of the bulb, we need to divide the potential difference by the current. And I know I've got some of the voltmeter readings here. So if I wanted to work out the resistance of the bulb, I would need to do the reading from voltmeter 1, because that's the one that measures the potential difference across the bulb, which is 0.9. I would then need to divide that by the current, which I know is 0.1, and that would mean the resistance is 9 ohms. Remember that symbol represents ohms, so OHMS. And if I wanted to measure the resistance across the resistor, I would need the reading that is across the voltmeter 2, so V2, and that is 0.6. You'll get an exam question like this and you'll have some data in a table, and you just need to take out the right data from the table in order to get this information. So the resistance for the resistor is 0.6 divided by the current. We know the current's the same because it's in series, and that means the resistance across the resistor is 6 ohms. So the total resistance of the circuit is 9 plus 6, which is 15. And just to confirm how we know the total resistance of a circuit, we've got this final rule here. I've highlighted all the rules in yellow, which are the things you need to make sure you know. So total resistance of 2 or more components in series is equal to the sum of the resistance of each component. So total resistance, so R is resistance, total means that I'm talking about total resistance. R1 is resistance of component 1, resistance of component 2, etc., depending on how many you've got. So R1, measured in ohms, is the resistance of the first component. So that'd be the first component you come to as you go round the series circuit. And R2 is the resistance of the second component, etc. You might have 4 or 5 or 6 components, and they'll just be R1, R2, etc. Adding more resistors in series increases the total resistance because the current through the resistors is reduced and the potential difference across them is unchanged. The more resistors you have, this increases the total resistance.